Are we on? Testing? Am I still ugly? Hey guys, it's Jason Wampler here. Another episode of the Rocket Minute. I sure hope nobody can hear my madness. Okie dokie. As usual, I'm gonna have to put a Walmart macaroni salad on hold. You know, I look the way I eat. I eat like crap. So, anyway, some exciting news. Whatever this nonsense may be. Oh my God, it's gone. Where the hell did it go? I had a coupling for this stupid thing. You know what I did? I actually think I threw it out. Oh, there it is. Okay. So tonight we're gonna have a long episode. We're gonna make a couple of motor housings for this rocket. You know, these aluminum rockets. First of all, I want you to notice my handiwork on both sides. I cut the angle. Let me get that there. Work material there. This guy right here, setting number 3, which is on the back side here. You can see a little speed switch. It's a brand new tool by Warrior. I'm not spending more money this month. My name is Jason Wampler. I'm the host. This is the Rocket Minute. I want you to hit the like button, hit the subscribe button, and leave a comment, leave vulgar comments, but make sure they're detailed. If I'm off in any way, shape, or form, I want compliments, comments, concerns, questions, etc., etc. I need your feedback. People don't know they're doing the wrong thing if other people don't tell them. So nut up. Be brave enough to tell me. I'm looking at a little red circle. I like that. I invested $15 in a tripod stand with a light and controls. I gotta tell you, Walmart is the greatest thing since sliced bread or original macaroni salad. I might end up eating in front of you. That's what a pig I am. But anyway, so I wanted to show you some things that I had done. I have progressed towards. This tube right here is basically the same. This is the tube that I got for $2.50 from Lowe's. This is the same as this tube right here. I decided I'm going to go ahead and dump these guys. I just really do not like the appearance of this aluminum. The finish is just absolutely horrible. And the problem is they anodize these tubes with dull aluminum anodization. You guys, I don't really know what you did that for. You give a smooth finish to aluminum, but you paint rust, you paint iron to look like iron. I don't get that either. So anyway, I'm in the process of getting the anodization off the top of this, but the aluminum underneath is kind of scrappy too. It's kind of like pot aluminum where it hasn't been boiled and mixed properly. Aluminum is actually electro-pulse smelted bauxite ore. I know that's a mouthful, but it's extracted from bauxite ore, which looks like square honeycomb. That's just how it naturally occurs. It's called bauxite, B-O-X-I-T-E. It's a wonderful material. Alcoa, Aluminum Company of America, which is what that stands for. Alcoa is the biggest producer of aluminum, at least in the northern North America, possibly in South America, possibly the world. And American aluminum, it is the best aluminum in the world. American steel can't be beat. But anyway, so I just wanted to show you that I did that. It's getting to be around 9 o'clock. The cats, Valencia and Paxton, are now getting used to Nora coming inside the house. My manager told me I cannot leave food dishes out, so I am not going to do that anymore. This clear plastic, this clear sealant that I'm getting from 99-cent store, you kind of do get what you pay for. So I'm going to stick to the stuff that costs about $6 or $7 out of a squeeze tube that comes from, I think I turned it in, that comes from I go there all the time, Lowe's, Home Improvement Center. I gotta clean this up. And this stuff is just doing a nasty job. I don't really like it. Kind of adding to the weight too. Anyway, this is the upper section of the rocket. So I cut these hold on before I jump ahead too far. So I cut these in at an angle. I have to tell you right now, this tool I got for less than $18 from Harbor Freight. It's equivalent at what do they call it? What do they call it? Professional hardware and tool stores would end up setting you back probably about $100, which makes you wonder exactly what the markup strategy is for these places. I never really buy tools from Lowe's and I don't go to Home Depot anymore. I'm boycotting them as per aforementioned reasons. But you know, it makes you wonder, these tools are only worth so much. They're manufactured overseas for pennies on the dollar, 1/10 of a penny on a dollar. So why they get marked up 10,000% is beyond me. Somebody somewhere has to make some money. I wanted to show you this material, and that's the first thing I want to do. This material, if you can see, almost fits inside of this. There's a difference in it. I can't really machine this material down very much. The wall thickness looks like about it looks about, not 1/8. Well, it's probably about 1/8. The wall thickness in this is 5/16, I believe, on this, which is 1/16 greater than 1/8. So 4/16 obviously reduces to 2/8, which reduces to 1/4. You know what? I screwed up again. Never mind. Let's leave math out of it. Math is ugly and makes me cry. But this material, what I'm going to do right now is I'm going to cut this material right here at this hip. This is a plumbing fixture, an emergency plumbing fixture you get from Lowe's. The whole packet came with about 3 other parts, and some seals. Cost less than $4.50. So bargain basement hunt. You don't need to be spending dozens of dollars. You don't need to be spending $100 on a kit. Guys, I'm showing you how to make this stuff with hardware store parts for pennies on the dollar. Now, if I ever get any feedback that somebody's abusing this technology that I'm sharing with you for malevolence, violent purposes, heaven forbid anything that is a terrorist that causes terrorism, anything in that nature, I'm not going to hold this channel anymore. I'm going to shut it down. And believe you me, I rail against terrorism. I'm a U.S. citizen. I do not believe in violence. I don't like violence. I don't even like arguing with people. You keep peace with your neighbor. As far as I'm concerned, live and let live. Leave people alone. But anyway, that is pretty much that. So the first thing I'm going to do is I'm going to cut this section off here to get this section of coupling material here. Again, I want to say that's 1/8 because double this width looked like it almost looks like it'd be a quarter. Yeah, it'd be a quarter. I don't know. I have to measure this. I'm going to get myself a plastic micrometer. They're like $2 at Harbor Freight. But, you know, it seems to me I have a Mitutoyo sitting around here somewhere, a metal micrometer, the machinist micrometer, and those are made in Japan. Mitutoyo is the standard for a machinist micrometer. If they want to measure the inner outer diameter of something they're manufacturing. I see Paxton wants to be part of the production day. You're a good boy, kid. He gets distracted around this time of night. And I do have to yell at him a couple times, but he really responds. He's a good boy. Paxton, you want to say hi? You want to say hi? No, he doesn't. He wants to bother me and he wants to get involved. So I'll cut this here right now. But let me explain to you what's going to have to be done to fit this particular material inside this material to serve as a coupling. The coupling that we need to join these, sorry buddy, hit it with the face. Join these two pieces together, make the full length of the rocket. Then we're going to do the anchor pieces. Tomorrow's segment, we're going to be continuing on this rocket. We're going to be doing the anchor pieces for the recovery system. We might even do a basic electronics bay, or we might run pressure tubes up from these motor tubes into this fuselage here and somehow create some type of veneer. I haven't made my mind up as that regards, and it looks like well, look at that. Paxton wants to sit in my lap. He's such a good boy, and he's a strong kitty. I'm amazed by this cat because he has very, very silky, soft fur. In fact, for the first couple of months of his life, I thought this was a female cat. I still called him Paxton, but I thought it was a she. And then upon closer inspection, I determined that he's in possession of things that make a man a man. So, and now they're more pronounced than ever. He acts a little loopy around this time every night, around 9-10 p.m. It's like a full moon around this place. Both cats are making noise. And right now I'm overwhelmed with the smell of cat pee-pee. But I'll take care of that after the video. Okay, so anyway, so we have this piece. So this section right here is going to lay to the side with the other materials on the bed, as well as its upper fuselage section. We're going to cut this with this, and I got to hurry up because it's getting too late to run loud tools. So, okay, and it's not turning on because I don't have it plugged in. And Paxton's taken my cat, one of my two cats, is taking up station at my feet. Okay, great. He's actually attempting to scratch the rubberized floor mat. Cat's claws won't do any damage to that, so if it's not the corner of an expensive piece of furniture, it's the rubber floor mat. And I'm happy. So here we go. Oh, one other thing. I need to get a drink. This is root beer with melted ice. That guy drinks too much. The taxi just ran off. I gotta be honest with you, I need this tool. I cannot return it, get money, or I run out of money at the end of the month. But I'm working on another source of income that should be coming in on the 10th of May. Keep your fingers crossed. But I love the way this cuts. It always cuts with an offset. So there's a little shark tooth ridge or a little bump ridge right there. But I'll flatten that down. This is scrap. I can't use it for anything, so I'm just going to throw it out. So I spent $4.50 on that whole kit just to get this. However, I think it was worth it. Let me turn that aside. You know, guys, you're going to discover the more you get into these projects, you're going to realize something. Number one, time flies when you're having fun. And number two, there's no such thing as enough desk space. So here we go. We're going to turn this on again, trying to even the paint lights up on this. Okay, so that's the best that's going to do. We're going to bring out the big gun block sander here. I always convert all my tools to 10 and 12 and 15 foot cords, and you're going to notice the practicality that I'll explain that. This isn't tool time, this is the rocket minute. So we're talking about rockets here. You know, ain't talking about love, etc., etc.
So, day two, you ready? What's the plan? Hit me. Yeah, I'm not sure. I'm still trying to figure the examination.
Okay, so here we go. I have a deburring tool. I really need to stop by McFadendale on
like testing a chess computer.
I don't know the name of that street it's on in Anaheim. McFadendale, look them up online to get some more blades for my deburring tool. Sure, I can get a nicer, cleaner cut. There you go. So, but this doing it externally is a little bit of a task, but it can be done as well. By the way, folks, I know this is kind of this is in my bedroom / office in a 1-bedroom apartment. I'm going to clean up. I'm going to vacuum and clean the carpets after this. I'm going to go do a trash run. In aerospace, it's good to clean up after yourself, keep things nice and clean and neat. Otherwise, the mess is going to build up. You're going to get overwhelmed with mess and stink, and it's going to be discouraging. A sloppy, disgusting, dirty, disheveled environment can be discouraging. Then again, depending on your taste, it can also be rustic. Part of a Norman Rockwell painting, you know, little shop of horrors. Okay, here we go. It actually changed the subject of the sitting on the ground. Guys, I don't mean to not complete actions tonight, but like I said, it's getting close to 9:30. It's a late shoot. I'm really excited about the new tripod with the red light I've got. However, given the nature of how loud my tools are, well, that didn't do much, but better than nothing. So here's what we're going to do. All right. This little area just bothers me. Well, you know what? That'll be, I don't know. Hold on. Okay, so I'm deburring it right now. I don't want deburr and demacaroni salad, so I'll keep that away from that. Okay, here we go. Just kind of roll it and drag it. This thing, the problem is this deburring tool is getting really, really dull. So, and it's doing an ugly cut on this material. This stuff is stronger, but it's a lot more brittle too. It's not as flexible as regular PVC. Really rubberized, flexible material, but not too flexible. Deburring tools work very well on brittle material like the hardened PVC. That stuff that I attempted to use with an upper body tube, the opaque white stuff that I got from Polygon Plastics. That was a really, really big mistake. That was a lapse in judgment on my part. I ended up throwing that stuff out because it was just too brittle and it was way too heavy. Any impact over 30 miles an hour, it just caused that to bust up. My level 2 project, I don't want that to happen. Still trying to figure out the recovery system for my level 2 effort as well, but we'll see about that later. Okay, let me go over this again because here, I'm going to turn on this tool again. I'm not going to shim down the outer surface of this with that. I'll have to break out the belt sander. And I can hear people walking around upstairs. So the concept is for this to fit in this, serve as a coupling. I'm going to have to remove, anyway, this is going to, this outer diameter of this is going to have to fit in the inner diameter of that. So I'm going to have to remove the material from the outer diameter. I've done that before. Not the best way, but you're going to find the hardest things to get for a rocket. Three things. A motor that works properly, that fits your rocket, coupling material to join the two halves of the rocket together, and a good old-fashioned nose cone. I can show you how to scratch build nose cones, but it's a lot of work. I got somebody who could do mold work for me too, but I have to reach out to the guy and see how he wants to handle it. Let me take a look and see what time it is. I need a timer. and it is 10:02. Well, tell you what I'm going to do for this next operation. In practical consideration of my neighbors upstairs, I am going to go ahead and close the window behind me because we need to cut off sections of the motor, and we need to start making the motor. We're at the 22-minute mark. It's not mandatory to go to an hour, but I'm going to be honest with you. I'm getting pretty hungry. I got to do day-end office work. I got to relax. I took an involuntary nap this afternoon, 1 hour. And I woke up and I was disoriented, and it took me a while to wake back up. That's happened to me once before, but I don't like to sleep deprive myself. But as an educator, as a government contractor, an engineer, and somebody who owns a small business, I've got a lot of things to do. So, anyway, okay, so here we go. Let me close the window behind me. This is the stuff that always scares the kitties. Not me reaching back like this. Okay, I'm not all the way to this window. The lock for the window wasn't set out far enough properly, so you pull back on it. You really got to yank on it and push it at the same time. It's about a couple millimeters off.
Are you fucking kidding me? Did it get on you? No. It's all right. I got it. You're wasting your time talking. Or doesn't understand it, but just give it a minute.
Anyway, okay, so thinking what else? Oscar Isaac in the movie La Mahina. There's a movie I'm watching right now. He acts like a real creep, but you find out why he does a lot of drinking and drugs and changes man's personality. I don't like it when men talk to women like that. So, but anyway, it's just me. Okay, so here we go. We are going to cut this material. My determination is I'm going to pick a random length, but I'm going to have to match the other end of this material to a random length. And here we go. Oh, same thing this time too. I have got to plug the tool in. You can't do anything with anything if you don't plug the tool in. So here we go. It's nice to be able to sit down. It's nice to be able to see my own face in reflection. That's how I set things up. Because honestly, there's no one else helping me right now. When I generate more income, I'm definitely going to hire help. That requires that I keep my own appointments. So I'm really scrambling. It's just amazing. It's just me, 2 cats, and a 1-bedroom apartment. But like I said, with work, being a government contractor, filling out 3 different grant applications, maintaining my vehicle, which is busted. I mean, it works, but it needs all sorts of maintenance and repair. Just running around and such and so forth, working on this second source of income coming up May the 10th. I'm just amazed. At 53 years of age, I don't remember time ever going by this quickly. It just seems to me like maybe I'm enjoying myself too much. So, like they say, time flies when you're having fun. Let me see if I've got this tool plugged in. Anyway, okay, let's get into it. I'm going to take an arbitrary length. This right here. This rocket is fairly on the heavy side, so I'm just putting larger motors in it. Actually, I'm at a setting of 4. Even up the pant legs on that. 4 seems to be perfect. I could dial this thing up to 6. It just vibrates and rambles like a demon. It's a very, very loud tool at full setting. And it cuts quickly, but it's hard to control when it cuts that quickly. So I slow things down, take a little bit of my time. I think 4 is a happy medium. The tool's quiet enough where I can use it at that speed, and it's slow enough to where I can control what I cut, because I want as close to a right angle cut on these tubes as possible. I mean, even first time through, reduce the amount of assembly or machining, fabrication, and assembly time. So here's what I'm going to do. with this. And guess what I brought? It's in my pocket of all the darndest things. My Milwaukee pen. I was griping about that last night. I always forget these silly things. Sometimes it's like I don't know what it's like. It's like I don't know, like a mental block. I'll mark this here, just a rough mark. I mean, you don't have to be anal retentive about exact lengths, but you do have to know the difference between machining things closely versus close tolerances when in critical areas and critical applications. I'm going to give you an introduction to that, but the honest to goodness truth is you need to know when to be accurate and fanatical and anal retentive versus where you can afford a little bit of slop. There are certain ways to do things properly, but again, if in other areas you don't have to spend as much time. This pen is going in the tool bucket there. I got a new tool cradle. I love it so far. That's 99-cent store. Guys, after I cut this motor, it is kind of late and I do need to vacuum the room and take out the trash. So after we cut this, I'm going to finish up. We're like at the 25-26 minute mark. And then we'll continue tomorrow, but in the daylight, we're probably going to end up having about a 1.5 to 2 hour session tomorrow, but we'll see about that. So here we go. We got this out of the way. This is rough cut motor tube. Let me cut the other motor tube, and then I'll sand the tube down, and then we're going to call it quits after that. Okay, so, all right, so we're gonna plug the other tool in. I'm kind of really sheepish about doing this after 10 p.m. Let's get a hustle on this. I'll wrap these two tools up. I'm gonna organize the boxes, but I'm not doing that on your time or on recording time. There you go. Just get the stuff will go in bulk stock. Let's get both of these here. That down there like that. Oh, that's right. I have to fold my laundry too. Loud. Okay, so we got these pieces and this piece. Everything's going in this rocket. I'm on the bed over there. It's out of sight of the camera. This is an extra piece. On that note, that is it. Tomorrow I have an online phone conference at 12 noon. So, sorry, I'm blocking myself. So what I think I will do is we're gonna start at 10 a.m. and go to 11:30, and then we're gonna finish fabricating the lower the actual motor housings, and I'm gonna draw you a picture of describing how we're gonna set up the cartridge and the nozzle. And folks, the interesting thing about I'm doing it again, blocking my face. Can you see me now? But anyway, what was I going to say? The nozzle on a two motored rocket is interesting. It's not at all what you think it's going to be. Bell nozzles with single throats and then vectoring thrust straight down the bottom of the rocket are one thing. But on the Titan 6, the twin engine rocket that the port side engine blew up on, the one we talked about in the last video. If you take a really close look at those nozzles on those solid fuel boosters, it's very, very surprising. It is very unusual. It's unlike anything you've ever seen before, because the offset nozzle, there's an offset nozzle that was literally almost 80% the size of the actual nozzle that was facing away from the centralized downward nozzle, which is only 10 to 20% regular size of the nozzle for that motor, but 80% was vectored at an angle of almost 32 degrees. So that means something. So that nozzle for those rocket boosters, it had two different vectored exhaust sections, and that means a lot. That has a lot to do with how we're going to attain the stability and flight of this twin engine rocket that we're building. I also wanted to discuss some other theories with you. So what we're going to do is we're going to do a little bit of lab work, just a little bit of this, a little bit of fabricating and loading these sections of the motor so we can attach them to the lower airframe itself. But what I want to talk to you about is the theory of nozzle design, which is going to lead into how, in fact, you're able to determine what the right nozzle is for a twin engine rocket. I developed something called Lily class 4-power rocket. It's basically this with two more motors, and that gets really complicated because each of those nozzles has a main nozzle and a couple of vectored nozzles on the side, or the nozzle, the downward thrust nozzles and the facing direct bottom of the rocket, and vectored nozzles at an angle. Number one, okay, how many? I would choose at least two for Lily class 4-power. I might end up choosing two or actually even three for the nozzles on this, because you want to have what's called, put this aside, that's not relevant, that's overstock. How do I explain this? With a rocket with four fins, the guidance fins control basically the one axis, two axis. You have two basic axes on a vertical launch rocket, the A axis and B axis, one that goes through sideways and one that goes through between you and the rocket itself. That's two axis. Two axis control is the absolute bare minimum for any rocket vehicle if it's launching vertically. As far as missiles that launch horizontally and cruise missiles, it's military. I'm not even gonna bother with that technology, and I don't know it. I don't want to know it. I don't do anything military. But with two motored rockets, with the Lily 4 class rockets, the Lily class 4-power rocket that I developed, two rockets are on one side of the two boosters on one side of the rocket, two boosters are equidistant on the other side of the rocket. Well, they don't form a complete pattern all the way around the secondary or lower fuselage piece, the part that transitions to the upper fuselage piece. They're grouped together in twos, so the groups of two are equidistant from the other one by 180 degrees. Full circle is 360 degrees. That being the case, as I mentioned in earlier episodes about setting those motor casings or set those upper motor tubes, you have to be very careful. If you want a Lily, like if you want a 4-engine rocket with two packs equidistant from each other by 180 degrees, you have to set them at 180 degrees. But I got to tell you, you have to line the motors up to each other on two different axes, and then you have to trim the pant length on top and bottom of the two together, and the two together have to be trimmed, the pant lengths with the other two, and then on top of that, when you have two perfect groups, set them down on a flat surface, make sure they don't rock back and forth, so they're not mounted like that, they're mounted like that. Then you have two pairs, and then you have to be able to set them at the exact correct height on the lower step long axis fuselage they mount to, and they have to be equal. They have to be equal to each other in height, down here and up there, equal to each other in length, and equal to each other in pairs as well, and then they have to be set 180 degrees apart. However, that is kind of it. But here's the thing. If you goof up when pairing those two rockets together and one's offset, one's a little higher than the other one, it's not going to sit correctly on the central fuselage, the mounting fuselage. It's going to be crooked, so it'll be equidistant in the front, but it'll be off in the back. Folks, first of all, one motor is off at an angle. The rocket's not going to be stable in flight. So when you develop the Lily class 4-powered rockets I will be showing you how to develop, you've got to be careful. Everything has to line up parallel. I talked about the sandwich compound, plane theory with compound tubes, two in the outer bigger than the one in the middle, which is usually how it works out. And again, you've got to set things up carefully. You've got to be careful, because if you don't set things up one step at a time in progressive order, it's going to, the fault, the mistake you make is going to amplify down the road when you try to really assemble things. You want a good looking rocket aesthetically, but like I said, I don't know how many hours I'm going to be putting in this rocket. You could end up putting close to 100 to 150 hours in one of these rockets, because you're doing things painstakingly and you double check your work to the umpteenth degree. And I encourage that. However, eventually when you start knowing what you're doing, you pick a rocket design that you like, you keep refining your technique, and then you move on to another rocket design. The more you familiar you get with one rocket design, the quicker it'll go. But don't learn that sense of personal discipline where you take things step by step and follow my instructions. I'm almost inclined to write a book about it, but you have to be careful, because if you don't do things right, if you don't line up these rockets to the central fuselage and then to each other correctly, you're going to have a rocket that looks terrible. You're going to have attachment and fastening issues, and you're definitely going to have launch and flight stability issues that you cannot control. And if you make mistakes that are bad enough, you put 50 hours into the rocket, you can't fix these mistakes, and guess what you do? It's the labor is expensive. You go to the hardware store, you spend another $20 for materials, you start all over again. It's a learning experience, but you're not going to make it to the next rocket meet with a launchable rocket, because you put yourself behind, because you made mistakes, because you weren't disciplined, you won't follow the instructions, you didn't do the measurements and set things up correctly as I was instructed you. Your sense of discipline as it relates to forcing yourself to be an accurate craftsman is going to bite you in the bottom. It's actually going to cost you a lot more money and take a lot more time to just bypass little checkpoints to ensure that your workmanship on small matters doesn't snowball into bigger matters and bigger mistakes. It's going to take more time for you to correct mistakes than it is for you to just take the time up front in advance and do things correctly. We're going to do a lecture where I'm going to just write things down. Good luck reading my handwriting, but we're going to do things step by step. The 2-engine rockets, as big as we're going to get, we'll get into Lilly class 4 power rockets later on. Then we can get into stuff that's exotic, like 6 and 8 engine rockets, but those will be a lot bigger. When you get into rockets that have more than 4 engines, like rockets like the Delta 6 that has 5 or 6 motors, then you're getting into matters of advanced geometry and trigonometry, placement dynamics, booster poopers, etc., stuff like that. But you got to understand, with that much fuel, that much weight of fuel, once the fuel is spent and that particular solid fuel motor, it changes to CP. So we're going to have to worry about that as well. We kind of have to worry about this now. When we do 6-engine rockets, you're going to have to do a lot of calculations to make absolutely positively sure, number one, you have the right materials, number two, you have the right fastening methods, and number three, you have a design that's sound. You can pattern your designs after me, but if you're like me, you're going to want to go off and do your own designs. 6-engine rockets are interesting. They're hard built, but they're very rewarding. Anything that's that challenging is also rewarding, and you'll get the respect and admiration of your fellow Rocketeers. And if you got the right stuff, I say go for it. But the higher you fly, the harder you fall. So be careful, watch out. Start engage in habits, keeping your work area as clean as possible. Mine is kind of relatively somewhat, but I got to sweep up the vacuum. The other thing is, again, folks, when you engage, you force yourself to be disciplined. You force yourself to take the time to do things right from the beginning. Don't let things slip. Don't gloss over instructions. Don't skip steps. Don't say, well, I'll just eyeball it. Sometimes you need to measure. I need to measure all the time. I'm guilty of eyeballing things too much, and I've learned that I have limitations in my vision. I have to use techniques and measurements and math to ensure that just because I'm eyeballing it, that when I'm eyeballing it, it's eyeballed correctly. And there's some things I can't do by intuition or by just eyeballing it. I have to use techniques. Well, this is where personal discipline comes in. You have to be disciplined and make absolutely positively sure you are going to commit to doing these small steps and slow down and just take the time to do things right initially. That way, you don't have a catastrophic building failure down the line, whereas you have to scrap the entire project. I've had projects, I've had 4-engine rockets that I've had to throw away. And I spent nearly 250 hours on one rocket leading up to its basic construction. And I'm looking at the thing and going, this is a goofy pile of crap. I didn't know what I was doing. I had to throw the whole thing out. I was able to cannibalize some of the parts off it, but the parts I cannibalized, I wasn't happy with either, because I started finding structural issues, weight, material issues, as I ended up throwing the whole thing out. And I spent 250 hours of my life at the age of 50, this is about 3 years ago, building a 4-engine rocket without understanding. Hold on. You know what? Hold on just a second. I hear these cats getting into something that I don't think they should be. What the hell is going on? You little fuckers, you made it. Oh, we got food, I'm sorry. Hold on, guys. Hold on, guys. Hold on. I'll get it from you, Kenny. Jeez, man. Here. Eating yourself a little smart, huh? There you go. Just eat that out of your camera. I'm sorry, I hope you didn't hear that cuss word of mine. My cats are unusually intelligent. They know where the food is and how to feed themselves. And if they had thumbs and fingers, they would work the can opener and they wouldn't need me. I hope you didn't hear my expletive. I hope it was deleted. In the comments section, I am going to restrict the comments. I don't want the use of profanity, sexist remarks, anything about drugs, guns, or other weapons. No sexism remarks, no racism. Mostly religion, politics, sex, weapons, alcohol, drugs. So I am going to limit and restrict comments for my review. I said before, use profanity. I have to retract that. I'm trying to break myself, trying to break free of the habit of profanity myself. It subtracts from the credibility of myself and this channel, and it detracts, it turns viewers off. You know, fathers and sons and mothers and daughters, groups of young kids, young girls I've seen from high school and junior high school get together in teams to build one rocket. It's really not appropriate for me to use using abusive language on my own channel. I don't welcome abusive speech, hate speech. Again, racism, religion, politics, drugs, alcohol, weapons, anything of a licentious nature. I don't want to hear it almost like you sound like a terrorist. You want to shoot something down, join our club, and we shoot down model drones. I don't do that. I don't destroy things. I don't go on shooting trips to blow stuff up. I really don't like or appreciate that sort of thing. I have walked some channels on YouTube where they over rev engines in a Chevy 350, perfectly good engine. They want to blow it up. I don't do that. I used to be a mechanic. My job was to fix cars, not destroy them. So I really don't like that. I don't like or enjoy anything destructive or violent or profane or sexual, religious, or political in nature. This is an educational channel. This is for that reason. I'm not necessarily what do they say, pristine, pious, righteous over much, or holier than thou sort of person. But I want to make sure that other working professionals, like other working professionals who make a living with their YouTube channels, I want to make sure that I'm up to professional standards as well. Standards of decency and cleanliness, standards where the family can sit down together and watch one of my videos and talk about the exciting prospect of going together as a family and launching rockets. I'm not somebody who's an arch conservative touting the merits of arch conservatism or Christianity. That's both political and religious. I don't do that on this channel. I don't denounce things. I don't denounce things I don't like, but I don't support them either. So in your comments, keep it clean, keep it above ground. The more technical, the better. If you want to offer criticism, I welcome that, but just keep it non-abusive. So, and that's pretty much that. I haven't gotten any abusive comments yet. I haven't gotten any comments yet because I'm just starting on this, but I've got a lot of views. And to me, it makes me think that if I'm going to get that much publicity, I want to absolutely positively make sure that my channel is well received and that it's viewed as something that's safe for all ages. I want the reputation of this channel being an all ages channel. It absolutely positively is educational. One other thing I want to assure you of, and this is what's taken up this time in this video, and I appreciate that. I tell you, Oscar, anyway, Oscar Isaac's character in this movie La Marina is just absolutely reprehensible. Boy, what a misogynist! And I think this movie is the beginning of woke in Hollywood. But I actually support women's rights. But again, that's socio-political, so I'm not going to talk about that either. So here's where we're at. Lower section of the rocket. This is the upper section of the rocket. It's going to be joined on top like this. The rocket is so long it doesn't fit in the entire frame of the camera. What a surprise. This is the coupling. This is a coupling for the rocket section house. And then I'll show you how to use a belt sander with fine grit sandpaper to machine this down. It's going to be a paper thin coupler, but it's still plastic, it's still strong, but it's also brittle. That's how these temporary plumbing fittings are made. And I'll even up the pant leg on both. But anyways, interesting movie. But anyway, so that's that. So the coupling, I will probably, this is the upper section without the nose cone. So we still have the recovery system to do. We're going to figure out how we're going to get air pressure to the recovery system, push the two halves of the rocket apart. That have the rocket's recovery parachute and drogue, one of each, two cord halves, two anchor spools, lower anchor spool being one that is in the bottom of the rocket with a cooling baffle built in, which is basically going to be a copper scrubber. I might put some pure cotton, not pure cotton balls, like something you get from a pharmaceutical store, something like a Rite Aid. I may install that. I may put the cotton ball in between the two copper baffles. And again, we're going to do things step by step. The cooling baffle is to keep ejection charge from the ends of the rockets. The separation charge is delayed charge, which is GOEX, double F, smokeless gunpowder, stuff they used to load the blunderbuss. That exhaust gas tends to be very, very hot. I learned the hard way that the material that is used that comes off the tubes used for sodium vapor light insulators it's structurally unsound and just doesn't hold up to the high temperatures of the ejection gas charge push off the top of the rocket. I used that stuff for years, and after failure after failure after failure, I just couldn't do anything about it. So I've gone with the thin wall PVC. It's heavier, but it's stronger, and it'll hold up those ejection charges. But again, you want to cool the ejection charge as much as possible. So the lower spool will have that two bulkheads, two caged or glued together. Copper scrubber, copper Brillo pads, and some some flame-proof cotton balls in the middle. I might actually even end up using not something asbestos like. I don't like to say that asbestos is dangerous, but it's used as sound suppression and it's fireproof. It's heat and fireproof. Um, I tell you, it's a double-edged sword. You save one person from burning and from noise, but they get lung cancer 10 years later. So can't win for losing, even when engineers have the best of intentions. So this section is the lower section. This section is the upper section. This, of course, we're going to work on tomorrow, and we're going to machine down the coupler. I'll be very excited when I can join the coupler in the lower section with this section, but I'm not going to glue it in place because after we fabricate the motors, then we're going to have to work. We're going to have to work on the anchor spools. When we work on the anchor spools, that's interesting because attachment of those anchor spools is going to have to take place a certain way, and I'll show you how to do it, but it's going to be kind of tricky. I keep making the mistake of not putting the lower anchor spool with the shock cord and the cooling baffles on the upper part of the on the lower part, the gray part of the lower fuselage, the secondary lower portion of the fuselage. And the reason I say that is because the forward part of where the lower fuselage inserts to the upper fuselage, the large diameter, is actually. I'll keep doing that. Let me get a drink. The reason I do that is the perfect place to start setting up the lower anchor with the cooling baffle, and you can set things up right there. So as long as you're not too enthusiastic to join the motor tubes and fuselage to the upper fuselage, we're going to get that taken care of first. Now that's me being undisciplined and violating my own rules. There's a sequence of assembly, and there's a certain reason for doing that. These are small rockets. The honest to goodness truth, they're not entirely tear down. You can't tear them down and service them. Once they've reached their service limit, they're not rebuildable. Unfortunately, follow the instructions. Maybe you've written down measurements on a little notebook or stored them on your phone somewhere. Follow the measurements, remember the procedures, refer back to my videos, and build another one. Again, before we go anywhere and we do anything, we're going to test things. The most important thing is we need to get the calculations for center of pressure and center of gravity absolutely, positively dead on. There's no point in me teaching you how to build a rocket, and time after time the rocket science instructor we build, my channel fails because I'm telling you how to build rockets that corkscrew off the pad and auger in at 90 miles an hour and destroy themselves. So we want rockets that launch successfully. So we need to do our calculations. We need to calculate power to weight ratio, which is basically for both motors. So times 2, which is total impulse, which is thrust times duration. So the pounds of thrust times how long it's burning at that pressure. How long is the motor burning and thrusting? So that's total impulse. 2-engine rocket, you calculate that and you multiply it by 2 because you have 2 engines doing the same thing. Then you compare that to a table or chart of data, considering everything fully loaded and the rocket built up, but before flight, including the fins and the paint, the parachute, the drogue, recovery, shock cord, all the whistles and bells, including the nozzle and the decals. Then from there you calculate the power to weight ratio, make sure that's correct. Then you calculate center of gravity, and you're going to have to play around with the rocket to get that correct. But then there's the center of pressure. So power weight ratio, drag coefficient of drag, center of gravity, and center of pressure. Those are 4 main calculations that you're going to have to make. I can't tell you precisely how to do them on your rocket because I don't know you and I can't see you. I can tell you how I'm going to do it for this rocket, but you're going to have to follow procedure, but you're going to have to run the numbers yourself because you're building a different rocket. Maybe you're choosing other materials. Another thing, I'm going to be highlighting alternative materials. And folks, I got to tell you, I'm not entirely inclined to recommend craft paper tubes of any type. Definitely no balsa fins. I don't know what Estes and Quest are thinking. Quest has gotten more away from it, and some engineering factions in Estes before Vern sold the company, they wanted to do things on an engineering level that made more sense, but they were unrefined. And popular opinion won out. Non-engineering heads at Estes, they made engineering decisions, which I know takes place, and I don't like that because people who are not engineers don't know what the heck they're doing. It's like me trying to be a center guard for the Lakers. I don't play basketball. I don't know what I'm doing, but I'm an aerospace engineer. So if LeBron James wants to come over, help me build a rocket, LeBron, you're always welcome. I'll give you my phone number, address, and email. We have a whole lot of fun. Bring your kids too. So anyway, so that's that. So Estes has made several fundamental, serious mistakes in the way of design flaws of their rockets. And I got to tell you, I'd never build another Estes kit. They just don't do things right. I've had to re-engineer their kits time after time. Now, people like Aerobee, Public Missiles, definitely Public Missiles. Public Missiles builds very, very tough, strong rockets. They're heavy, but they won't break. If you're out there, they use plastic and aluminum and metal and hardware and everything. Aerotech still uses a cardboard tube. It's not cardboard tube is paper. It's not phenolic. Phenolic is I think might be wood pulp, but it's with the use of epoxy. It's sort of an epoxy resin mixed with wood pulp. And possibly some other materials, other synthetic materials thrown in. It's like it's like a dark mocha or coffee color. But I'm telling you right now, if you want to use phenolic, it's almost impossible to burn phenolic. So use this in high temperature applications, like anything on or near the reloadable motor system or single-use motor system itself. That's fine. But what I'm telling you, and what this discussion is leading up to, is I'm going to recommend a very small list of alternative materials if you can't find thin wall PVC. But these materials are going to mean you have reduced options for the materials that are available. Don't use parts from other kits, and don't buy stuff off the internet. I'll show you where to get this stuff. But if you have to make the sacrifice and use a craft paper tube, do it the way I do it, and then we'll talk about either CA vacuum bagging, or you can talk about a 24-hour set of epoxy and resin. We can teach you how to vacuum bag that way. That creates a very, very unique and difficult circumstance in that you can see some people just vacuum bagging the material and going over it with a block sander, and it evens up. Well, if you're a craftsman, you can do that. But if you can't, then you have to build centering jigs. You have to somehow, some way, get your hands on a wood lathe or buy one off of Craigslist or whatever. But you're going to need a wood lathe. See, and when you start doing your own motor systems, you're going to need a metal lathe. When you start cutting heavy-duty materials, you're going to need an arbor saw, rip saw, or band saw, preferably something that cuts metal. Not just one of these. We're building small-scale rockets, but again, when you want to get with exotic materials, you're going to spend the first 1 or 2 years of your life figuring out what's called process engineering, the process by which you make these compound materials, because nobody on the planet is ever going to have what you want, because nobody is as smart as you are if you want to be a rocket scientist. Anyway, so that's that. I've droned on, and guess what? The video turned out to be 1 hour long. So, broke my promise by keeping my promise. 1 hour long videos. Okay, so my overtaxed phone, my psyche, I'm going to call it quits at this point. It's been a lot of fun. I've got this brand new anyway, distracted by the move. I've got this new boom stand, and I'm loving it already. I got it for $15. It was on sale. Only $20 to begin with. And it's absolutely amazing. But I just love finding these deals and getting stuff at a discounted rate. It makes me feel good. I understand why women love deals and shopping. So anyway, the movie's distracting me, naked women. Ugh. So I can't even mention that. So anyway, that's pretty much that. My name is Jason Wampler. This has been another episode of the Rocket Minute. Hit the like button, hit the subscribe button. I do have one subscriber right now. The guy tracked me down and found me. Thank you. But I really want to catch a wind. I'm working on two things right now, setting up my own website so we can design and build. I can start selling rocket kits and rocket components. So when I make enough money, I'll hire help. I need a cameraman. My man, Ulysses Andrades, who is the founder of Dead Engineers Society in Mexico City, Mexico. My man, I need to talk to you. I need you as my cameraman. I got some help right here with the stand. Getting along good with my neighbors. It's Saturday night. I'm still having myself a good old-fashioned time. But yeah, we're working on the website. The other thing I'm working on is figuring out how to monetize my YouTube channel, because it never hurts to make money doing something you enjoy. Anyway, it's 2:43. I've got to run the vacuum. It's gonna piss my neighbors off. I'll fold laundry. I've got to eat. Never enough time in a day. Anyway, my name is Jason Wampler. I've been the host of another episode of the Rocket Minute, and of course, we'll see you tomorrow because we had so much fun today. We have to do it again tomorrow. Thanks a lot. Bye bye. Then I'm gonna get up, shut the camera off, and engage in more madness.